Welcome to On the Move, a podcast mini-series about wild animals, their amazing migrations, and how people are finding ways to free them up from all the things standing in their way. I'm Leah Palmer, a storyteller at the Nature Conservancy. On an early spring morning in Ellsworth Creek, scientists at the Nature Conservancy captured a chorus of birdsong in the iconic moss-draped rainforest. For 6 weeks, devices placed by scientists recorded sounds of the forest and snapped photos of animals when triggered by motion. These sounds and photos helped them understand biodiversity and animal movement in the forest.
So it's like the dawn chorus. When the sun first comes out, birds just like go wild. It's amazing. And they're just all singing at the same time. And people don't really know why. Which are cool. I mean, there's all sorts of theories, but it's another one of those things that's just like intrinsic animals loving life, or like just existing in the world. And
that's Maia Murphy-Williams, Associate Director of Science at the Nature Conservancy in Washington, introducing me to the concept of life histories. Life histories is a science term encompassing the strategy plants and animals use to survive on the planet, their behaviors at different ages, reproductive patterns, seasonal movements, everything we expect to happen before they die. In 6 weeks that spring, Maia and her team captured over 91 distinct bird songs in the forest, and they're identifying more as the study continues. She cautions me about giving human qualities, motivations, or emotions to animals, but to me, their calls sound joyful, connected, contented. Here's the interesting thing. If Maia recorded birds singing in the same forest at a different time, say in winter, the sounds would be entirely different. That's because, like many creatures on the planet, birds are on the move. Migrations have always inspired us, but our planet is changing. What does that mean for the way animals come and go with the seasons? Well, I decided to find out. Over the next 6 episodes, I take you with me on my learning journey. More than a dozen top experts agreed to sit down and shed light on the way animals pursue historic migrations, playing out their life histories in our modern world. I'm Leah Palmer, and you're listening to On the Move. So what is a migration anyway? A quick Google search defines migrations as seasonal movement of birds or animals from one region to another.
Birds, for example, migrate to seek food or better temperatures to wait out the winter months. Whales migrate to warm waters to have their babies in a safe place, and then they return to colder waters that have more food in different seasons. Smaller animals tend to move less, but in the forests I study, the coastal temperate rainforests of the Pacific Northwest, the larger the body of the animal, typically the bigger home range they need. So that means the more space they need to live out what we call their life history strategy.
Maia grew up in Washington and has spent her career studying wildlife across the West. At the Nature Conservancy, she focuses on how conservation interventions affect wildlife.
What else about me? My background's in wildlife science, and I've always just had a real love for the creatures. But when I was going through undergrad and grad school and my fieldwork jobs, I kind of like had this nagging feeling of like I really care about wildlife and our wild spaces, but humans are in crisis too. The environmental template on which humans and animals depend is in crisis. And so sometimes it felt kind of incomplete to just focus on wildlife in kind of the traditional academic setting. And so that kind of led me away from academia, away from just studying one specific taxa or animal, and towards looking at how climate change is affecting our landscapes and the wildlife that depend on it, and just more broad conservation focused on people and nature. And that led me to the Nature Conservancy, where you do have the opportunity to look a little bit more big picture and how this all fits together. But I would say my first love is wildlife, for sure. And that continues to be a guiding force in the work that I do.
My ears perked up listening to Maia talk about how both humans and nature are in crisis as the climate changes. Did you catch her mention of our environmental template and how it's changing? Well, I did a little searching for a reliable definition and some context. First of all, our environmental template simply refers to the physical and chemical structure of a habitat. It includes temperature, light, soil, moisture, nutrient availability, basically all the characteristics of a place that allow life, yes, even humans, to thrive. Maia says these key features of Earth are changing. But what's causing this change? Well, I'm realizing that human actions like our dependence on fossil fuels, our disruption of natural habitats, and the pollution of our clean air and water have rapidly reshaped this environmental template, pushing the needle on climate change further and faster than ever before. The impact of that change is hard to fathom. More and more people are experiencing climate disasters, dealing with the impacts of a warming climate, sea level rise, and severe wildfire events. But there are places in the western United States where the impacts are hardly noticed, where the potatoes still grow and cities still bustle. Yet underneath the veneer of normalcy, farmers are planting climate-resilient crops outside the traditional growing season. And sportsmen can't seem to harvest deer, elk, or fish in the places they once always were. And if humans are changing the way we relate to our environments, I can assume animals are experiencing these changes too. Somewhere in our relentless pursuit of growth and development, humans modified habitats, initiated severe declines in biodiversity, and changed the planet forever. Maia tells me a diverse ecosystem is essential to ecosystem health. The more diverse an ecosystem is, the more resilient it is to disturbance and disruption. She tells me that monitoring biodiversity is a primary method for researchers to determine overall health of an ecosystem. Diversity is key for human and animal systems.
That's why it's really important that we're monitoring biodiversity on the landscape, and especially with climate change and changing land use practices. So with logging, with flooding, like as the climate is changing and as humans increase their impact on the landscape, that changes where wildlife go. Right, where they shift, where they move, and by monitoring wildlife biodiversity, we can get a sense of what's happening on the landscape, what areas might need our attention.
There's a lot of listeners out there like me who maybe don't use the word biodiversity in their everyday conversations. And so I thought it'd be interesting to ask you, what does that even mean?
Yeah, that's a great question. And maybe I'll start with a general definition of biodiversity. In general, it's a measurement of the number of species like within a set geographic area. So say in your local park, there might be squirrels, there might be deer, there might be various types of birds. So it's counting the number of species, and then often there's some estimation of the amount of each of those species.
Maia and I spent some time looking at photos she's captured on motion-activated wildlife cameras.
Okay, here it is. Look at that.
Oh, oh my goodness. Wow. Okay, is this in Ellsworth?
This is Ellsworth.
Ellsworth Creek.
Yeah.
Yeah,
This is Ellsworth
it's
Creek.
this beautiful sun-dappled forest with a lot more mature trees. And then kind of following its mother is this baby bear.
Yeah.
Beautiful.
And it's June 1st
Mm.
is the date on the camera. And the baby bear is teeny tiny. And so this guy is probably very fresh.
Ah,
Yeah.
wow.
Yeah.
Wow, thanks for showing me.
Yeah.
That's a very special thing to see. I still get giddy at the opportunity to talk with experts like her, who have a pulse on animals big and small that move through TNC preserves in Washington. She showed me migrating songbirds in trees, cougars hunting a snack, baby black bears tumbling behind their mamas and becoming acquainted with their legs. I'm beginning to get a sense of what biodiversity really looks like. I can see just how important a healthy habitat is for living things to thrive. This makes me think about ancestors in my family who lived through dramatic migrations. Some moves they chose, and others were imposed. When I think about wildlife migrations, I can't help but see echoes of human movements, too. I asked Maia if there was anything humans can learn from animal migrations.
I keep coming back to the concept of connectivity and how important that is for animals, and especially as the physical landscape is changing. And that's kind of a parallel I see with human populations, right? Is like both the physical climate and the political climate is constantly changing. You know, an elk or a grizzly bear has no idea if it's in Canada or the US, right? They're always like going back and forth between borders. I think what we can learn from animals is the arbitrary nature of modern borders. Because how an animal exists in space is looking for food, for community if it's an animal that is not solitary, for shelter, for all these things that like both humans and animals need to exist. And that is what kind of defines their geographical area, right? It's not arbitrary borders that humans have imposed on the landscape. I mean, especially you look at a lot of our states. I mean, some of them are squares. Like I lived in Colorado. It is a perfect square, you know? And that is not something you ever see in nature ever. Like you see boundaries along mountain ranges or along rivers or along forests. So you think about like back to our squirrel or our elk, like what they need to survive. And I think that's something we can really learn from animals is that movement across borders to seek safety, to seek shelter, seek a good life that we all deserve is just the most natural thing. And it's been happening for millennia.
Support comes from the Nature Conservancy. In the Emerald Edge, we support Indigenous and community leadership to restore coastal rainforests, protect wildlife, and strengthen communities across Southeast Alaska, British Columbia, Oregon, and Washington. Learn more at nature.org/emeraldedge. Experts have been studying wildlife migrations across borders, this most natural thing, for a while now. But in the last few decades, their questions have changed in response to accelerated change in the climate. I sat down with Josh Lawler to discuss how new questions have informed what we already know about animals on the move. Hi, Josh. How are you?
Good. How are you?
I'm doing pretty well. Thanks for joining me and talking about wildlife migrations today.
Yeah, I'm happy to. Thanks for having me.
Of course. Well, Josh, before we jump in, I was hoping you might introduce yourself a little, maybe tell us your name and your title and what that means.
Sure. So my name is Josh Lawler, and I'm a professor at the University of Washington. I'm also the faculty director of the University of Washington Botanic Gardens, and I'm the co-director of something called Nature and Health. And all that means I'm a professor, I teach classes, I do research, and then I help direct the academic activity that happens at our botanic gardens. And I help direct a group of researchers and practitioners who are interested in the connection between time spent in nature and our health.
Wow, that sounds like really fascinating work, and it must be something that's driven by passion. How did you get here?
It is. So I've been interested in conservation, probably since I was little. My parents used to take me on nature walks and hikes, and every summer, our summer vacation was camping on Cape Cod in Massachusetts.
Mm-hmm.
Even though I grew up in the suburbs, I grew up spending a lot of time outside and had an appreciation for the natural world since I was a kid.
I came across Josh Lawler's work through a collaborative mapping project he worked on with the Nature Conservancy called Migrations in Motion. It's a model that helped me visualize how historic migration pathways for birds, mammals, and amphibians may change as climate change accelerates and alters their usual habitats. Now, this isn't your typical map, static, familiar, green, brown, and blue. Instead, this map comes to life in streaks of magenta, cyan, and yellow. Visually, it's nothing short of stunning. If you'd like to check it out, search Migrations in Motions map, and it'll come right up. Underneath this gorgeous science communication tool, there's a message. Here's Josh again.
So, many years ago, over 20 years ago, I was doing some research with the EPA, and we were looking at where to protect biodiversity. And so we were trying to plan out where one might put parks and preserves and protected areas. And as I was doing that, I realized about the same time all the researchers working on those kinds of questions realized that climate change was going to move species around, and that planning for where species are today might not be as effective as planning for where they might need to be in the future. And so I said, okay, instead of just using maps of where all these animals and plants are now, we should be using maps of where they're likely to be in the future. And so that got me interested in that question. And I started doing the modeling that would project where species might need to go in the future. And so that map of all the streaks of color is an animation of lots of individual potential movements that species might need to make in any given place to get from where it's suitable climate-wise today to where it's going to be suitable climate-wise in the future.
Okay, let's pause here for a quick definition. Did you hear Josh say he started doing the modeling? Modeling allows scientists to create simplified representations of a complex world system. They help us visualize information that may be difficult to observe with the naked eye. Now you know. Let's get back to my conversation with Josh. He's about to really break it down for us.
So what we started with 3,000 species of vertebrates in North and South America. And for each one, we wrote an algorithm, a bit of computer code that asked what are the climatic conditions that species exists in today. So if we look at where the species is on the landscape, where is it warm enough, cool enough, wet enough, dry enough, does it have long enough summers? Where are those conditions on the landscape? And that gave us an equation of those climate variables or environmental variables that would determine where the species is likely to be. And then we plugged into that equation projected future climate data coming out of global climate models, general circulation models. And that told us where on the landscape the species was likely to be in the future. So that's the sort of the basis for the modeling. And then on top of that, we said, okay, now we know where they are and we know where they're likely to need to be in the future. How do they get there? And that was a separate set of modeling where we modeled these little pathways from where they are today to where they're likely to be in the future. And that involved modeling how they might avoid things that most animals are probably not going to easily move through. And that's human parts of the landscape, such as big agricultural fields or highways or other built infrastructure. So then we modeled all these little potential movements across the landscape that avoided those things for each of those different species.
It's fascinating. I imagine along the way you were surprised by some of the things that you ended up modeling in this final result. Can you talk to me about what you learned and describe an aha moment that you had as you were doing this research?
Sure. Yeah, there are maybe two things that stood out to me. One is that if you look at that map, there are some clear pathways that emerge. And I don't think we really expected that. In retrospect, we probably should have expected that because there are portions of the continent that are going to facilitate movement and those that aren't. But there were very clear pathways that showed up, one in Western North America that went from Mexico all the way up into Canada, following the Rockies and up through the Canadian Rockies. And it was sort of a Yellowstone to Yukon pathway that went all the way down to the Yucatan. So that was impressive to us. It was this long pathway that we didn't quite expect to be so prominent. And then in the eastern U.S., the Appalachian Mountains stand out as a potential route for species moving north. So how clear those pathways appeared was impressive to us. The other thing that was sort of an aha was at the same time we were doing this work, I had a student that was using those same models that tell us where the species might need to go. She was looking at whether mammals in particular would be able to keep up, whether they'd be able to go as fast as they needed to go to get to the climates they needed to get to. So we had one group of people who was looking at how are they going to move across the landscape, what routes, and then she was really interested in, well, can they even make it there in time?
Wow.
And so an aha that came out of that was that there would be a good percentage of mammals across North and South America that in any given place might not be able to move fast enough to get to those climates they need to get to.
And what happens to an animal that maybe can't make it to more habitable conditions?
Well, there are several things. One is we might be able to make it easier for animals to move across the landscape. And so we could restore habitat, we can create corridors for them to move through. Because you remember some of the modeling involved landscape factors that they can and can't move through. And so removing some of those human barriers, bridges over highways or passageways through agricultural fields, those kinds of things might help. We may need to pick some species up and move them. And that has in the past been a fairly controversial idea. In the past, it's been called assisted colonization or assisted migration. It's often now called managed relocation. And it all means picking up a species and moving it from where it is now to where it will need to be in the future so that it can survive. And that's probably going to be something we reserve for cases where there really is no other way to allow the plant or animal to move. But those are some things we can do. And even though we found that there were a lot of places where species couldn't keep up, there were other places in the species range where they might be able to keep up. And so it may mean prioritizing protection or management for certain parts of the landscape where certain species have a better chance of keeping up.
Now, if you're like me, you might have some alarm bells going off. It's troubling to think that the 3,000 species Josh studied may be motivated by climate change to pick up and leave their current home ranges to find more suitable habitat. This situation seems urgent. The good news is, Josh thinks there's a lot of things humans can do to support plants, marine animals, birds, and mammals that are already relocating in surprising directions. Scientists and conservationists are working overtime to do their part. They're reducing our carbon footprint by citing renewable energy sources, advocating for policy that protects nature, and working with Earth's natural ability to store carbon and other harmful emissions before they degrade our atmosphere. This is sometimes called natural climate solutions, by the way. But have you ever wondered what you can do to make an impact? While I had Josh's attention, you know I had to ask. I wanted to just kind of get into your thinking about how we mitigate climate change. And I think I'm a lot like most of our listeners, where we hear that this is happening and it feels daunting and maybe induces like grief even at a really extreme level. Or maybe that's not the most extreme response. Maybe that's a very healthy response. But it sort of feels like something that's out of my hands. And I was just curious, you talked about what some of our experts are doing, but what could just everyday people like me be doing?
Our personal choices throughout the day can help too, and how we choose to get from place to place. Not everybody can bike or walk to work or places, but some of us can take buses and public transportation.
Mm-hmm.
And even the type of fuel we put in our car, whether we have electric vehicles or we ride electric buses, or those things all help. Even things like diet. And so meat tends to contribute more to emissions and carbon in the atmosphere than does a plant-based diet.
Mm-hmm.
And so the more we shift from a meat-based diet to a plant-based diet, the better it is for the climate. So there are things like that. There are things like the light bulbs that we have, whether they're more efficient, and the other devices in our home, how efficient they are. And so there are definitely things we can do on a personal level that reduce our own footprint. And one of the things, particularly for scientists, one of the things that increases our footprint is flying. And so travel, we all love to travel when we can, but that's one of the things that has a big impact on carbon in the atmosphere is flight, because it uses so much fuel.
That's a really good and helpful list. I think a lot of what you just mentioned is so actionable right away. Support comes from the Nature Conservancy. We're working with communities toward clean energy solutions that protect wildlife and western landscapes. Learn more at nature.org/care. I'm curious if there's any one or two species that really just have a soft place in your heart, or maybe a better way to frame that question is one or two species that are worth watching.
Yeah. So I'm going to talk about one species here in the Pacific Northwest that I think everybody at least know its name. If they haven't, they probably have not seen one in person because they're very elusive. But the wolverine is a species that just comes down into Washington a bit, but we have them in Washington, and they depend on snowpack in the winter, and they depend on a fair amount of snowpack, and they don't like people. So they're elusive. They like to be farther from people, and they need a fair amount of snowpack. And those are things that aren't good in today's world to need. It's dangerous to need those things. And so the projections of, we've done several different kinds of models for wolverine, and they all show that things don't look good for wolverine. And that's what you see across the literature too. And so that's a species that I think we should watch out for, and that we'll have to be very careful about if we want to keep them on the landscape.
This may be a dumb question, but what's the importance of keeping a wolverine around?
Yeah, so it's not a dumb question. And I mean, there's the question of like, why do we care about any one species? So I'll answer the wolverine question. We've lost over time a lot of our carnivores, particularly our higher level carnivores, that are higher on the trophic scale, and those carnivores have an effect on everything else in the system. So they affect the populations of ungulates or other herbivores, and those herbivores, when their population numbers grow because they're not being preyed on as often by the missing predators, they can affect the landscape and affect the vegetation, and that in turn affects habitat for other species. And so even though it's one species, they play a role in a larger system. And so losing those top predators or losing any species that's playing its role in the system can have an effect that's larger than just losing a species.
Now imagine just for a moment you're in Josh's position, knowing what he knows. How would you share your findings with the world? Well, he and his co-authors published a paper called Projected Climate-Driven Faunal Movement Routes in 2013. It served as source material for the map. I know from my work as a science communicator that for critical information to reach everyday people, sometimes you have to break the mold, and that's just what the Migrations in Motion map did. My colleague, Dan Majka, is a developer for the Nature Conservancy, and he's one of the masterminds behind the map. I emailed him to ask why he chose to share Josh's data in such a unique way. Let me share a bit of his response. Dan says he and his colleagues were influenced by an interactive wind map they loved and felt it was the first time they saw a map that made data come to life. They had the idea for the data visualization when Josh's paper first came out in 2013. It took a year or two to get funded, and then it sat on his computer for a year after he finished it, because no one knew what to do with it. Dan writes, quote, I think the remaining aesthetic choices I made, the layout and bold cyan, magenta, yellow, and black process colors used for the printing process, came from an interest in modernist and post-punk design aesthetics, and feeling bored with naturalistic cartography. Most of the time, when I make maps, I strive to make them align naturally with the world around us, blue water, green forests, etc. But most of my cultural interests align more with experimental art and music, and the Migrations map felt like a good opportunity to try something fun. Dan's innovative choices on this map earned him some distinction. In 2018, it was featured in a small exhibition in Paris, and in 2022, it went on to be featured as a performance art piece at one of the world's most prestigious art and architecture exhibitions in Venice. Dan says he's, quote, the only scientist within TNC who had to sign a contract in French where I was referred to as l'artiste, which is endlessly funny to me. I'm Leah Palmer, and this is On the Move, a podcast miniseries about wild animals, their amazing migrations, and how people are finding ways to free them up from all the things standing in their way. In the next episode of On the Move, we'll explore seasonal salmon migrations, from the streams where they spawn to the ocean where they feed, and their harrowing journey back home. Join me as I talk with experts who say human cultures are at risk when salmon migrations are threatened. Special thanks to Maia Murphy-Williams, Josh Lawler, and Dan Majka for sharing their expertise. And thanks to my storytelling team, the brilliant creatives behind On the Move. This episode was written and produced by me, Leah Palmer, with support from Kate O'Neill and Dustin Solberg. Custom artwork was created by Simek-Sloniker with support from Mitch Maxson. Web and social production come from Danielle Kagen and Traci Swift. Find more from this series at nature.org/onthemove.